Hello and welcome to the third part of the VBA tutorial introduction for this development workshop. I'm going to be talking today about some new and more interesting things than the past few days. A few days ago we spoke about the introduction, and yesterday I spoke about the syntax and some various pieces and elements that maybe were not that interesting. But today I'm going to talk about programming logic. Basically and generally when we speak of programming, we speak of the logic which drives it, and you need to understand how regular logic can be applied to a program while you're creating it. I briefly spoke about this in the past module, but the difference between designing a program and writing the code, that's the logic. You design the logic and you type the code. The below steps are the programming logic used to write a simple program in Excel. I will explain at the end what this program does. In the below set of logic, we assume that there are two spreadsheets containing only data in column A. Both spreadsheets have different account numbers. Some exist duplicated on both spreadsheets and some are unique and will not be found on both. Essentially what you're going to see here is this is a function called a VLOOKUP, where you have a long list of accounts and you want to segregate exactly just a few of them from a separate spreadsheet. You don't have to write it this way, obviously, but this is a very simple and easy and direct method on how you can take a look at it and work through it. So the first step we'll see here is selecting sheet 2. So you assume that on the screen you'll see two spreadsheets. The first one is the long list, 100,000 accounts in it, and sheet 2 contains 10 accounts. Now we're going to search through all those 10 accounts. So in step 2, we determine that the last row used on sheet 2, in this instance it would be 10. So we would see 10 accounts. It would go A1, A2, A3, all the way down to A10. Then we set an array. This is a list within the system memory to hold the account numbers from sheet 2. Everything from 1 to the last row. So in this instance, it would be the account number in A1, in A2, A3, A4, all the way to A10. So it starts from A1 and it loops all the way down to A10. It takes all those account numbers and puts them into system memory. Then, obviously number 4 here, that searches through each row and places account numbers in the array. Then it goes back to sheet 1. Now that was where, as I explained, we had the 100,000 rows. We then determine the last row used on sheet 1. For this instance, that would be your 100,000. Then we go to cell A1 and we go through the entire account list from sheet 2. So A1 would search through the loop of 1 to 10 numbers from the second sheet. And then in number 8 here, if the cell in A1 account number is found from the sheet 2 account list, then we change the cell color to yellow and go to the next cell, A2. So what's going to happen here is you look at A1, if the account number is 1, 2, 3, 4, 5, if the account list on sheet 2, out of those 10 accounts we had looked at, if one of those, even if it was number 2 on the list, was 1, 2, 3, 4, 5, or if it was number 8 from that same list, 1, 2, 3, 4, 5, it would find that in this lookup here, and it would change the color to yellow. It's pretty simple to look at it this way. Now, I can show the code for this, and I'll do that on the message boards. So I'll actually take Excel, I'll go into it, I'll open up a module, and I'll write this exact piece of code out for you so you can take a look at it. Because right now all we're doing is looking at the logic behind it. I'll go into some more coding techniques in the next module, but this will be a good practice one to start off with. What we're going to see in number 9 is if the account number was not found from that 1 to 10, then we go on to the next cell, A2. Regardless of what happens here, in number 8 we go to cell 2, or number 9 we go to cell 2. So if it finds it, it changes to yellow. If it doesn't find it, it does nothing, but it always continues to the bottom. Then it repeats steps 8 through 9 through every row in sheet 1. So this would be a very, very long process to work through. On the sheet 1, it would go 1 to 100,000 rows, and it would times that by 1 to 10 because it's trying to find those exact account numbers. There's obviously a lot more logic and code that could be put into this, but this is a good starter small program to take a look at. And then we're going to sort sheet 1 by the cell color. So that's just another small piece of code. That would take all of the yellow cells and put them all at the top or at the bottom, so we could very easily see where they were looking at. Excuse me, yawning. Number 10 here, we look at programming logic. The program logic written on the previous sheet is used to compare two lists of accounts from separate spreadsheets. It first appends the data from the second spreadsheet into system memory, called an array, then cycles through each account on the first spreadsheet to see if it's found in that array. If the count is found, then it highlights the count on both spreadsheets, like found from both spreadsheets in yellow. It then sorts the spreadsheet by color, as I just mentioned. This function is a variety of a VLOOKUP function. If any of you are familiar with this, but it allows for many separate properties to be set up and can be incorporated easily into larger programs. What that means is basically if you wanted to do a substring search, you could look for anything in that sheet 1 that contained 1, 2, 3, 4, 5. So if it had a bunch of numbers before it, if it had them after, if it had a dash or anything within that, you could also look up that. There's a lot of implications and reasons this could be used, and you don't have to limit it to just the logic that I explained, but I think that's a good start. Just a couple of fun pictures I put in here. This is Thinking Like a Programmer. It's a book by No Starch Press. I've not read it, but I was recommended before. I don't know if you'd want to read it. I don't generally read anything, unfortunately. And what did I miss? This is just a funny joke I had. This is the way that a programmer would think in relation to a real life scenario. My wife says, please go to the store and buy a carton of milk. And if they have eggs, get 6. I came back with 6 cartons of milk. He said, why in the hell did you buy 6 cartons of milk? Because they had eggs. This is a good example, in my opinion, of what happens with programming that you type into your computer in relation to logic in real life. Obviously, what she meant was if they have eggs, get 6 eggs, and not what was written here, but you can see the logic difference here on what you'd actually code in. Because if you coded exactly what the wife said at the top here, that's your result, which would happen at the bottom. So you have to be very specific when you're writing programming logic. This next piece on defining variables is something I'll go into. A variable is basically anything you want it to be. You define the name, the type of variable, then you place something into it. An example of a variable you might see in your life are name, phone number, age, color of hair, date of birth, if you're awake, and the current debt. The type of variables are what you want them to set up to be. You define a variable with the below syntax, starting with the word dim. And honestly, I can't remember what dim stands for. I think it's dimensionalize, which doesn't mean a lot to anybody. Then the variable name, then as, then the variable type. A variable cannot start with a number, so you couldn't start off with 1 name, 1 age, 2 color of birth, or color of hair, or anything like that. And it cannot have multiple words, meaning you can't have a space in it. The proper way to set up a variable for ease of reading is lowercase, then uppercase, and then a number. So we call a variable a starting number by starting number, as you see right in this area here. This is just a very clean way of writing your code. You don't have to write it this way, but this is the way I write them. So if you're going to follow my code, it just opens the variable up, so when you're writing code you can tell where a variable is, because it's very hard to actually tell unless you're looking at color coding and stuff like that. But I'll write them like this. It makes it simpler. And you cannot use predefined function variables as names. These are the code pieces you write in. So for example, the words if, for, and, sub, etc. Excel will give you an error if you try to use one of these. So for instance, if you saw here the word dim, if you put dim and tried to use dim as a variable, that gives you an error. These are some types of variables that we have to define. If you don't define them like this and tell your computer to allocate resources to these types of variables, then they just turn into anything that they think is appropriate. Your computer will assign a type of variable to the definition. So if you don't use this word dim and set them up like this, The first time you use name, if you put the word James in it, it'll try to put it as text. If you try to put 01, it might store it as a number, but you may want it to actually say 01, whereas in Excel, if you type 01, it would become a number and just does bad things for conversion. So always define your variables. You can stagger them beside each other like you see down here with commas between them. So if you have a whole bunch of the same variable types, you can put them beside each other. For instance, if you had a whole bunch of string variables like first name, last name, middle name, you could put dim f name, comma, m name, comma, l name, comma, sorry, no comma at the end, but just as string. I'll go into staggering variables later and you'll see how they work. And the various types of variables defined are commonly used for specific purposes, and I'll define them each below. Each of these variable types, basically there are more, but you'll never really use them. I think in my whole time coding at CIBC, I've only used them 6 times or so, and that's been 5 or 6 years so far. And coding before that in the past 20 years, I don't think I've used many other ones either. So the string variable type is used to house any type of item you want. It can contain numbers, but you won't be able to use those numbers for calculations unless you convert them to a different type of variable. So if, for instance, name was 0, 1, 2, 3, 4, 5, you can convert that later to a long or integer value and it'd become a usable number. An integer value is used for smaller whole numbers, like 1, 50, 100, or 500. If you go, I think, up past about 12,500, it limits it and the system will tell you have an issue. So that's why you use the long. The long type is used for larger numbers but contains smaller ones if needed. You could put a 5 in there, but it can support up to, whatever this is, a trillion, I don't know, and 50,000. So it can contain those as well. Now, you don't have to use integer ever. You could use longs for everything, obviously, and there are reasons to use both. I generally use long almost always now. It used to have something to do with system memory, but your system has so much memory now that you're never going to max it out. The date is a type that stores in date in your memory, 1/1/2013, 12/25, 2015, etc. It doesn't store it in this exact format. It stores it in this strange number system within your system memory, and when you drag it out of that system memory, it looks like the date again. It can be used for date calculations. So if you took Christmas on 2015 and subtracted January 1st, 2013, it would return however many days are between there. It's pretty special. You can put date or time in there as well if you want, but don't worry about time at the moment. I'll get into it later. Boolean is used for true or false. It can only be true or false. It has a flipper on it. Now you could also use obviously integer and call it 0 and 1, which is just exactly the same as this. But sometimes Boolean is nice because it has the word true or false in it, and it's easier to code and follow your code as you're writing. The last one I have written here is a double variable type. It can store large numbers with decimal places. It can be typically used for percentages or dollar and cent values, such as the ones written here. You can hold a whole bunch of decimal places into it. I don't know how far it goes, but you'll never max it out. I don't think so anyway. And large numbers are in there. Double's pretty useful if you want to do a lot of the stuff that we might do, but yeah, you'll find the need for it if it arises. And then, of course, we look at defining variables too. And as I mentioned in the last page, this shows how to stagger them. We declare variables using the dim function. Then we place in the variable name, and then we set its type. If you don't declare the variable, when the first type of data you place, it becomes the variable type, and you'll find that your program may not function the way you want it to do. And you can stagger them together, as I just mentioned, by using a comma, like here, dim name and color of hair as string, or phone number and age as long. This is a typo. I shouldn't have put an uppercase here. It should have been lowercase. And then the variable define are just the containers though, and they contain no data until you put something into them. You can either define the data you want inside the variable itself, or you can grab data elements from elsewhere and put them in the variable. I generally define all my variables together, and then as I go later on, I will define what goes in them. It just looks easier this way. I do it this way. It makes the code flow better, and it looks a lot nicer. So obviously you see here name, and then in double quotes, this is how you put name. If you take a variable and you make it another variable, it will dump that same information piece into there. So in this instance, what you'd see is what we see down here. Name equals James, color of hair equals name. Since name was defined above, it makes color of hair equal name. So as we see down here, they both equal James. And then the phone number is a number, just like this. If you put a 0 at the front, it cuts it off, so don't do that. I can show you how to set a 0 up if you want. At the beginning, you'd use a string variable and dump it inside the double quotes, and it would keep it in there. Again, we see here phone number. This is my work phone number. Age equals phone number, and so in the variable above, we see the below output, which really doesn't make much sense, but shows you how you can place data into variables by whatever you want. It's either dependent on another variable, or you can define them as they are. So if you didn't want to do this, you could write it like this, but both equals the same exact thing. This is useful because you could take phone number and say that, and then you could put here age equals phone number plus 1, and it would add 1 onto the 5 at the end here. Above here, you could put James, and then color of hair equals name. You could put an and symbol and double quotes black at the end. Then it would equate down here and we call it James Black. Anyway, it's the same thing. I'm going to leave it off at this point. Tomorrow or the next time that I write one of these modules, I'll go into the if statement and get defining a few different program types that we can use, a few functions, etc. And I'll continue on the process as we go. I hope you found this tutorial to be very useful. If you want to look up a proper usage of both of these items, this programming logic breakdown, and I'll show a module that contains all of these different data types and show small uses of them on the forums as well. Thank you. Bye now.